So this question asks us to solve a first-order differential equation where the dy dx equals y over x minus y over x squared, and we assume that x is greater than 0, and it gives us an initial value where when y equals 1, when x is equal to 1, y is also equal to 1. The nice thing about this question is it gives us a hint to make a substitution of let u equals y over x. I love questions with hints because I know where to start. So why don't we actually just start with the hint? So if we let u equals y over x, then I can recopy my question and find dy dx equals u minus u squared. Now I have a slight problem because I have dy over dx instead of du over dx, but not to worry, we will find a way to resolve this problem. So if we let u equals y over x, then what we're saying is let y equals u times x. And let's differentiate this whole equation by x. So we effectively get dy over dx equals, by chain rule, we get u prime x plus x prime u, which is du over dx times x plus u times dx over dx, which is just equal to 1. This is just 1. So we have dy over dx equals du over dx times x plus u. And so now we can take this whole thing and substitute it here. So now we can have du over dx times x plus u equals u minus u squared. And we see that the u's cancel out, and we actually have a separable equation. So we have x times du over dx equals negative u squared. If we cross multiply, so divide the u squared over to the left hand side and divide the x to the right hand side and multiply the dx over to the right hand side, we'd have 1 over u squared du equals negative 1 over x dx. At this point, we can integrate both sides, and both of these are fairly easy integrals. Negative u, negative 1 equals negative ln x plus c. And so one of the things up here is we have the assumption that x is greater than 0. Because we know x is greater than 0, ln the absolute value of x will just be ln x. And so let's rewrite that. Actually, let's multiply the whole equation by negative 1. And let's drop the absolute value sign. So 1 over u equals ln x plus c. And remember, we defined u equals y over x. So 1 over u is actually x over y equals ln x plus c. Now we want to isolate for y. So cross multiply, or I would divide ln x plus c equals y. And so if you rewrite it the other way, y equals x over ln x plus c is the general solution for this differential equation. However, we do want a particular solution because we know that this function passes through the point 1, 1, 1. So let's substitute in 1 for y and 1 for both x's. So 1 equals 1 over ln 1 plus c. Ln 1 is just 0. So therefore 1 equals 1 over c. C equals 1. So a particular solution for this problem is y equals x over ln x plus 1. And that is your final solution.